So we're asked to find the area of each parallelogram, so I'm going to do number 1 here. So because it says parallelogram, I know that the formula I want to use is A equals B times H, so I need to write that down. I then am going to substitute in the values that they give me. The area they don't give me, so that's what I'm going to be determining. They do give me a base, and they do give me a height. Now, I have a choice of 3 numbers. I'm only going to use 2. Because I'm using base and height, I need 2 numbers that are perpendicular to each other. So this base here is perpendicular to this height here, so those are the 2 numbers that I'm going to use. Now, the base is this value here, 20, and now here's what I want you to do is put the units right in there, because this base is 20 centimeters, not just 20 centimeters, times then 12 centimeters. And now I simply have a multiplication problem. And kind of like we were doing when we worked with radicals, you can multiply non-radical numbers by other non-radical numbers, or you can multiply radicands by radicands, but you can't mix them. It's the same thing here in that I can multiply the numbers together. So the 20 times the 12 is 240. And then I can also multiply the words together. This is centimeters times centimeters. Now, when we have centimeters times centimeters, or if we have a number multiplied by itself, I could write that in shorthand by doing centimeters squared. So the area of this parallelogram is centimeters squared. So if we apply the arithmetic to the numbers and we apply the arithmetic to the words, you can see that we'll always come up with square units, and that's why the units in the area problems are squared. And that's why the units in a perimeter problem are not squared. And it's why the units in a volume problem will be cubed, because you're going to be multiplying words together just like you multiply numbers. So I want you to write the formula, I want you to substitute in with the words, and then I want you to give me the final answer. This step here you can skip if you'd like, but I just wanted you to see that when you multiply the same thing by itself, we write that as squared. Alright, let me jump over here and do number 3. In number 3 here, again, they find the area of the parallelogram, so I know the formula I'm going to use is base times height. Now, the area value is not given to me, though that's what I'll be determining. The base and the height have to be perpendicular numbers. Well, if I wanted to use 4, there is no number that's perpendicular to that, so I cannot use that as my base. If I want to use 5.8, I have this 3.5, which is perpendicular to the opposite side. But in a parallelogram, we know that opposite sides are the same, so this opposite side is also 5.8. And so the 3.5 is perpendicular to the 5.8, so I can use those values in my formula. So my base is going to be 5.8 meters, that's the units, and then my height is 3.5 meters, so I'm going to simply multiply those two values together. Multiplying those two together, I get 20.3, and then multiplying the words together, meters times meters is meters squared. And so you can see that the area of this parallelogram is 20.3 meters squared. Now in this parallelogram, we're asked to determine the length of CF. And as I look at CF, it's perpendicular to this 13. So the 13 and the FC are a base and a height. So I know it's a parallelogram, so if I want to use the formula base times height, I don't know what the area is. If I'm using 13 and FC as a base, I have 13 inches is my base, but CF, I don't know what the height is either, so I still have an H. Now the problem here is that I can't determine the value of H because I have two variables that are missing in my formula. In order to determine the value of H, I have to know A, right? Because I can determine the value of any variable as long as I know all of the other ones. So in this problem, I'm asked to determine H. The problem that I have right now is that I don't have the A, which represents the area of this parallelogram. Without the area of the parallelogram, I can't solve for H. So what I have to do then is think about, well, if they don't give me the area, but that's the number that I need, then there must be a way for me to calculate the area in some other way. Well, I know that the area is equal to the base times the height, so if I'm going to calculate the area, I need a base and a height. I need two numbers from the diagram that are perpendicular to each other. Now, as I look at the diagram, I notice that AB, which is 10, is perpendicular to this value here, DE, which is 12. So I can use these two values to calculate the A, which is the number that I'll need over here. So I'm going to go ahead and substitute those in. So I have a base of 10 inches times a height of 12 inches. Oops, that looks more like an M. Let me fix that. A height of 12 inches. If I multiply those together, I get an A value of 120 inches times inches, or inches squared. And I wrote inches times inches because I want you to show you how this will help us determine the correct units when I'm trying to figure out or determine H. Okay, so now that I know what A is, let me scroll just a little. I can now take this value of A and put it over here in my other formula, which gives me all of the variables in this problem except for the one I'm trying to figure out, 13 inches times H. And now I can determine what H is, or FC. So to determine H, then I'm going to divide by 13 because the 13s will reduce, but I'm also going to divide by inches because that gives me all of the words and the numbers reduced to 1, leaving me just H. But because I'm going to do that over here, I must do it to both sides, and you'll notice that one of these inches in the numerator will reduce with one of these inch units in the numerator. I think I said numerator here. These inches in denominator reduce with this 1 inches in numerator, leaving me 1 unit of inches, so I have the correct unit of measure for my length, and then I simply have to divide 120 by 13. 120 divided by 13 is about, actually I should change my symbols here. Let me change this. So the height then is going to be about 9.2 inches after all of these values reduce. And again, if you use the units up here and you use the units here correctly, there's no guessing about what these units should be down here because they reduce as part of the mathematical process. In many cases, when we come to problems like this, students will always put inches squared here because the lesson's about area, and so they just think everything is units squared. And again, I don't want you to have to guess about these things. I want you to be able to know and to see how they're calculated by simply applying mathematical or algebraic properties that you already know. Again, what we do with numbers, we can do with letters or with words. Sometimes they just don't allow us a nice, neat package, but we can still use them.